Thank you for joining me for this video. I am Mr. Ish. I hope everyone's doing well. Everything you're seeing in this video is for educational purposes. Do not do this at home and get drunk. We're looking here at conversion of vinegar to booze. And you know, booze here represents drinking alcohol, ethyl alcohol, or you can also call it ethanol. We know vinegar here as acetic acid, CH3, C double bond, OH. When you spell it out in terms of atoms, you have a C2H4O2, vinegar. When we're converting into ethanol, we are saying CH3, CH2OH, and you know this right here would be C2H6O. Look at the comparison of the atoms between these two. Same number of carbons in both, but in vinegar or acetic acid, you have more oxygen atoms, you have less hydrogens. In ethanol, you have more hydrogens and you have less oxygen. What is that telling you? It's clearly showing you that this compound, vinegar or acetic acid, is more oxidized. This compound here, ethanol, is reduced. Therefore, you're going from an oxidation to a reduction, and now you need something which will help you reduce that. And that's the essence of this conversion. So we know we have to reduce this compound, which is in oxidized state, an acid which is oxidized because it's got more oxygens. And what is the item we will use? It's lithium aluminum hydride, LiAlH4, and it's also abbreviated as LAH, lithium aluminum hydride. Now when you start this reaction, you have to understand that the reaction is starting out under basic conditions. This right here is a very strong nucleophile because it's basic. It will be a reaction which will be something of the following manner that I'm showing you. Look over here, you have a complex. You have a lithium and an aluminum. Lithium is not really bonded to aluminum, but it's a complex association between the two because you know these are metals. Aluminum and hydrogen have more of a bonding than aluminum and lithium. Anyhow, you have to understand that this right here is a negatively charged compound. So it's looking like this. You have H, aluminum, then H3. One of these hydrogens, and this is negatively charged. Where is this lithium? Well, I told you the reaction starts out under basic conditions. Would you see this item right here in a base, acetic acid? Under basic conditions, you wouldn't see this because it would have dissociated off, and you would be seeing something like this, a carboxylate, because again the reaction starts out under basic conditions, so the acid would be deprotonated and it would be in a carboxylate form. Anyhow, what will be neutralizing this negative charge? The lithium will come off and it will associate with it. The positive lithium, the negative oxygen will associate with one another and it will put this oxygen out of commission. Now you have this negatively charged nucleophile. It's basic. This hydrogen is going to attack over here and it's going to bond to this carbon. What you will end up seeing is this. You'll have CH3, you have a C, you have O minus. You still have this O and Li, O minus and Li positive. Now you brought a hydrogen. You're going to get the conversion of this carboxylic acid into an alcohol by the donation of two hydrogens from lithium aluminum hydride. This negatively charged item will now associate with an aluminum complex, and we'll keep it just that. It's bonded to other items, but we'll keep it like that. Now what we have is another round of this base, aluminum hydride. The lithium is already interacting with that oxygen, and it will be something like this. It's negatively charged, but this hydrogen will again attack over here. What's the reason here at the beginning step why this negatively charged item is attacking over here? Because this carbon is receptive to such an attack because of the dipole differences between oxygen and carbon, and it's receptive to that attack. Keep in mind that the oxygen is electronegative. When you have a carbonyl group over here, the oxygen is sucking the electrons towards it. So this is more negatively charged, this right is more positively charged. The carbon has a positively charged character to it, hence is negative, has an affinity for that carbon. So we're seeing this negatively charged nucleophile attack the carbon again because again it has a positive character. When it does that, you have this hydrogen attached with that. So now we're looking at a CH3, we have a C, we have this original hydrogen which was coming from right over here, and now we have this next hydrogen bonding over here. What will happen when this attacks this thing right here, this complex, oxygen aluminum complex? It will break away. When it breaks away, you have the rest of this item which is O minus Li positive, and this item, oxygen aluminum complex, which I'm symbolizing as that, has broken away and it will go away. Now we have CH3, CH2, O minus, Li plus. This right here represents the basic part of this reaction, where we are looking at a reaction occur under basic conditions. Now the acid part of the reaction will occur. Keep in mind, we've got two hydrogens over here, and both of these hydrogens have come from lithium aluminum hydride. Where will the last hydrogen come from? Because we need to have an alcohol form. This has to become an OH. The last hydrogen will come from the reaction under acidic conditions. So this is where we've left off. We have CH3, CH2, and then oxygen lithium complex over here. We have oxygen aluminum complex, which has drifted off. Now the reaction will occur under slightly acidic conditions. We'll have a acidic reaction occur, or a reaction under acidic conditions. The last hydrogen will come from what you have over here in terms of the acidity and in terms of the water and the protons which are available. Is this come into play? You have a CH3, CH2, and then OH. This lithium will drift off. We're looking here at acidic reaction. We're looking here at a charge balance. We have a plus H over here. We have a plus Li over there. A positive one, and the reaction will be balanced. Of course, the end result is this ethanol, and it's going to exist in the form. It's not going to become CH3, CH2O minus. It's not going to deprotonate, because we're looking here at a reaction under acidic conditions, where this is exactly what you would see. Because the reaction is not highly acidic, it will exist in the alcohol stage, and it will not become a CH3, CH2, OH2 plus. That is, this oxygen will not impart on itself another hydrogen and become positively charged. It will stay as is. This lithium can now go back and be regenerated into your lithium aluminum hydride complex. Note, two of the hydrogens come from LaH. The last hydrogen comes from right here, a acidic environment, and it generates ethanol. It's a nucleophilic reaction which starts out under basic conditions, but then it ends under acidic conditions to convert vinegar to alcohol. And that's it for this video. Thank you.